Hi guys, welcome to Sprint 1031 Exunt Academia. Now it's been a while since we released Dogen. In fact, almost 2 years to the date because the last release 1030 was in January 2021, to our great surprise. And only now in September 22 we are back releasing. And in addition to that, there hasn't been a particularly productive release, if I'm honest. We only had two user-facing features, and they are not of particular note, really. So the first feature, so what I'll do is I'll quickly describe the features. The first feature was related to a deprecation or a decommissioning of some functionality. In the past, we had support for probing, and the probing, well, we always had support for probing varying forms, but the the bit that I'm particularly interested in is the support for dumping the probing data into a relational database. That feature was added recently, and we tried to add that functionality to make our life easier, really. We used to spend a lot of time creating JQ queries, and as I explained in the release note, these queries are not exactly readable. It's very hard when you go back to a JQ query a few months later to try to understand what it does and to modify it to do something slightly different. On top of that, you couldn't just do a JQ query because you needed to do more complicated things. You needed to do joins and you needed to copy and paste some files. And in effect, we ended up with more of a Unix pipeline with cats and sorts and grabs and so on, plus JQ. To do any useful work. And when you put all those things together, it was actually really hard to understand the querying that we're doing of the trace data. Now, the trace data is really useful because what it does enable us to do is enables us to see the state before and after a transform. But because the trace files are so large, they tend to be on the tens to hundreds of megabytes sort of range, it is not so easy to make sense of the diffs. We probably could, actually, I just did a restart of my machine, so it's probably not going to be easy to set everything up now. But the long and short of it is that it is not particularly trivial to find the needle in the haystack of the trace data. So the obvious thing to do is to say, well, let's just put everything in a relational database. Let's make very complex queries. Can it save as stored procs? And then we just evolve this library of stored procs over time. Now, that was what we intended to do, but in practice, um, querying very large JSON in Postgres is only marginally easier than querying it in JQ. It is a bit easier, and I'm sure that if we really truly understood the Postgres querying language, it probably would make a lot more sense. But we just don't have the time at present to really spend a few hours to really truly understand how the language works properly. And I still think that the syntax of the queries would see, for the person that's more used to SQL. Well, actually, as an example, let's just have a quick look here. So if I just do a quick search for JSON Postgres, hopefully we see. Well, in fact, there's a tutorial here. This should give us a gist. Um, so as you can see, there's quite a lot of peculiarities related to JSON, such as, for example, these operators that enable you to extract data out of existing objects. And there's also how these things then get applied to the existing SQL infrastructure, which makes it not quite as simple as just using SQL to query the data. So clearly there's a lot of potential, and clearly and this is one reason why we added support for this. But it is not quite as simple as we thought it would be. The second problem was that with the movement towards GitHub Actions, which we'll cover later on, we couldn't really continue supporting ODB. And the reason why is because ODB, the version that we use of ODB is version 2.5, which is still a beta version, although it's been released continuously for like 10 years or so. And there are no Debian packages for it, nor are there VC packages for the libraries, which basically meant that we were supporting our own internal build from using build2, which is a tool that also is not the most popular at present, which required a lot of overhead just trying to get our head around all that stuff. It was just different from everything else. And every time we updated VC package, we got a break, and then that resulted in more issues. So the long and short of it was that we decided to just decommission the ODB support. At present, we only decommissioned the relational model side of it. We didn't actually remove the functionality from Dogen. But because we haven't quite got to the reference products yet, we may have to consider when we get there, decommissioning it from the code generator altogether, or leave it as untested, which is not ideal. But the key thing really is that the functionality to dump the trace information from Dogen is now being removed. In the future, we are thinking about replacing it with MongoDB because MongoDB is designed to specifically to do queries on JSON data. It is not a trivial match because we are depending on the hierarchy of the file system for the trace data, and it's not clear how that would work in a flattened MongoDB world. But at least the query language for MongoDB at first glance seems slightly easier. Also because we use MongoDB at work as well, which means that we're more used to the interesting quirks of the language than we are with the JSON language. And it also means we only have to learn one language for two things, which is always a good thing. So all in all, basically it was deprecation of the functionality, and now we need to think about how we're going to bring it back. How exactly is that going to work? The second change that we did this release was, it's actually a feature for a change. And the feature can be demonstrated fairly quickly. So here's an example. Let me just change this to Portuguese, sorry, to English keyboards. So if we have a quick look at our codec model, the new feature was, let's see for PlantUML. So the new feature was, and if I put the cursor back, so the new feature was the ability to place a verbatim Dogen, PlantUML text, associate that with an element of a model. So for instance, in this case, the element model has got a couple of entries here that are PlantUML specific, and which Dogen just transports without any knowledge, and that's why we call this verbatim, because we just take whatever it is, whatever the contents of this field are, and then we place it as is into the resulting model. So hopefully, well, let me just search for this text. So hopefully we'll see that the text was copied as was, and you can see it's just after the model element, the element model, apologies. And the main reason why we did this is because when we moved away from dia, and I guess for good measure, what we can do is very quickly show you how this would have looked like in the dia world. So in the dia world, we had all these relationships that we added manually, which were really helpful because it really enabled us to describe the important relations between different elements within a model. And of course, these were added manually, and we just added them as we needed. So there wasn't really, we never thought too much about it. We never thought about the process that goes into adding these relationships. In reality, what's happening here is that we're doing a lot of filtering, because you don't really want to add every single relationship to a type. For instance, it would not be useful to have lots and lots of arrows pointing to std string, nor would it be to have lots and lots of arrows pointing to other vocabulary types, such as name, for instance. But other types, such as, for example, the containment between a model, an element, an attribute, model set, that's actually really useful, and we can give some hints as to the purpose of that relationship with the text. And this can't be done automatically. This has to be done manually. So the reason why this diagram looks quite readable is because a lot of care was taken in the way the information is displayed. Now, if we look at the very same diagram, once it's generated by PlantUML, the diagram is probably small enough that Dogen is, Emacs is not going to complain. We just add some horizontal scroll bars. You can see that this diagram looks a lot flatter there are no relationships here. And where there are relationships, such as in here, um, they are not quite as useful. Now, we did have the verbatim relationships that we just added, and you can see immediately how much of a difference that makes. It's already starting to resemble the diet diagram, not completely, but you can see with a bit more care, we can make it a lot more meaningful. Some of these relationships are, of course, obtained automatically, such as inheritance and so on. But other ones, such as the ones we described a second ago, those require a manual hint. And that is the functionality that was added this sprint. So it's a very small bit of functionality that's actually really useful. Of course, now what's needed is to go through all these diagrams and to add the relations where required until the state of the diagrams is as usable, I guess. So that was our second user visible feature. And if we resume our presentation, so pretty much that was it for the sprint in terms of user visible features. So what we were working on that was not user visible was we were migrating from Travis CI from Avware over to GitHub Actions. And that work was, as far as the Dogen product itself is concerned, let's just double check how we're doing for time. Yeah, okay, good. So the Dogen product itself has been ported across. It wasn't quite as hard as I thought it would be, really. And it is very advantageous because in the past there was, well, we tried not to make changes very often to the CI because, for instance, updating the dependencies was a bit of a nightmare. We need to rebuild all sorts of libraries using VMs and physicals for macOS and so on. And then we used to place those libraries in a Dropbox location that was then picked up by the build. And it had all sorts of quirks, wonderful, weird and wonderful quirks like that, which made it really difficult to use in practice. With the new setup, everything is done within the GitHub CI, and also obviously the GitHub CI is the same environment as the GitHub version control, which makes life even easier. It also contains support for storing the resulting binaries of a release, which is quite nice. And we can support all the operative systems without having to worry about that, with very little effort. And the last but not least, we are able to point to a version of VC package, a commit to VC package via the magic of Git submodules, very, very easily. So, for instance, at present, we're pointing to some past commit of a VC package, but by doing a Git update to this submodule, we can just point to latest. We've done this in the current sprint, and with that, would pick up things such as the latest push release and so on. So it's extremely easy to update that. And then, of course, once we do that, that triggers a rebuild of all dependencies across all the supported operative systems. So next sprint, as soon as we push this, Linux, macOS, and Windows will all rebuild with the right version of VC package and then generate the packages. So that's incredibly useful, really, with very little work from our side. And of course, VC package contains fairly large library of packages. I guess if you're a JavaScript or some such language developer, you probably wouldn't think much, but for C++ development, almost 2,000 packages is quite good across quite a lot of platforms. So VC package integration with GitHub is actually really, really, really good. And so whilst we spent ridiculously large amount of time this sprint working on that, and working on the nightlies as well, which we can have a quick look from here. Where is our C- dashboards? So as you can see here, we have the nightlies. They still have issues with it, but most of the tests are passing, and Valgrind is running as well. The key thing is that we now have C- integration with GitHub, and one warning or two here and there. But on the main, everything is working and all the builds are green. So that was the main achievement for this release. And as I also mentioned in the release notes, we haven't really been working for the last 2 years on just this release. In fact, we've been working on finishing the thesis. So what you see here is the complete set of documents that we created. This is the full set of papers. And here is just a subset, which was in the end used for the thesis. And all of that was published, reviewed, and the Viva, the final exam. And I passed the Viva, so that basically means I've completed my PhD program, which is quite good because from now on we can focus purely on the engineering without having distractions in the PhD side of things. It also means that the academic model for Dogen is more or less complete, which is also quite a useful thing. Now, I'd just like to make a couple of comments regarding the PhD itself. I guess 2 years to write a thesis is quite long. One advice I'd give to anyone undergoing a PhD program, particularly in computer science, is to remember that the thesis is the thing you're going to deliver, not the software, because we spend a lot of time coding and trying to make the code perfect. And to be fair, I wouldn't say that the code is in a state that I would consider to be particularly brilliant. We still have quite a lot of work to do to even just to represent all of the ideas in the thesis. But the bit that you have to understand, which was quite hard for me to understand, is that the purpose of a PhD program is not to release end user products. It's just to create enough. It's sort of like an MVP, but it's an MVP dedicated to the argument of the thesis. So what you need to do is you need to code just enough to prove the points that you are going to do work on. And then once you've done that, you should immediately start writing. Because if you leave, and this is where I was quite lucky that I had the advice from a good friend of mine, Tulio, who's done a PhD already a few years ago. And one of the advice that he gave me, which I think was probably one of the main reasons why I managed to finish the PhD in the end, was to start writing immediately. I kept talking to him every weekend about how I still had to do more coding and more development and so on. And he kept telling me that actually I should stop coding. And I couldn't quite understand what he meant. But it all kind of made sense once I actually started doing the final bits of writing. It literally took 7 months probably for the first draft, which was then taken apart by my supervisor, and then another 5 months for another draft that was good enough. It still required some more fixes, and then of course you still have the entire process of trying to organize the Viva, which probably takes another 3 or 4 months. So 2 years is actually quite a quick amount of time if you're working part-time, because everything takes such a long time. So one of the lessons I've learned is I would say you should optimize for the writing rather than optimize for the coding, and try to understand how much coding is really necessary in order for you to get on with the writing. Because you won't pass a PhD, you won't pass a Viva with brilliant software. You would pass a Viva with a half decent thesis, really. So that should really be the focus. And writing is really important. I think one of the very good things that I did was I started writing quite early on, so probably about 4 years ago. Not all, in fact, maybe 50% of the stuff I wrote was useful for the thesis in the end. The other 50% ended up being notes and basically supporting elements of the cast, I guess you'd say. For example, the notes in software in MD were not used directly, but it was a great way for me to actually understand the subject, the problem domain better, or the subject matter better. And it was also a great way for me to learn how to do academic writing. You need to learn how to be concise. You need to learn how to reference material. You need to, well, there's all sorts of things that you can only learn by actually writing. So it was very, very useful that I started writing quite early on, even though, well, as you can see here, there's a vast difference between these two. The thesis was very, very small compared to that, roughly half, if not less, than the complete set of documents that I wrote. Probably don't have to write that much, but I would say you need to write as much as is necessary for you to get the hang of academic writing. I also optimized for not doing any publications in external papers and sorry, I need to pause here for a sec. Apologies for that. I was very busy in this house. So where were we? We were just describing how we decided not to publish any papers in journals and so on. The main reason being that when you've got very limited time, as we did, it was hard to justify spending the time in the review process. Let's double check we are recording. Yeah, indeed. It is hard to justify the time it takes to go through the review process of a paper and particularly when we didn't expect any of these papers to be of great significance in the overall argument in the thesis. So, well, the first paper was just a set of notes, so that's not really something you'd publish. The experience report was actually a useful paper, and I think it adds value for anyone considering the use of MD, especially in finance. But again, the fact that this paper got published would not make any difference to the argument of the thesis. It just reinforces our analysis of the problem. And the survey of special purpose cogenerators as well. Very useful paper because it's enabled us to understand a bit better how cogenerators outside of MD work. But again, the fact that that paper got published wouldn't validate any of the argument in the thesis. So in reality, the only paper that would have made sense to publish is a summary of the thesis itself. And by the time you've done that, you've kind of more or less done the thesis. So I think for a part-time student, it doesn't make a lot of sense to be chasing, well, depends on exactly what it is that you're working on. But in my particular case, the development of a new methodology, it didn't make huge amounts of sense to develop a paper in isolation of the thesis, because the paper would be the thesis really. And the validation of the thesis, I can't see much of a difference between the validation of the thesis via Viva versus the validation of the thesis via paper. Of course, if I was trying to follow a scientific career, which is not the purpose of this exercise, I would definitely consider publishing as much as possible. But that was not the point of my exercise. So I didn't really worry about that. And I think that was a good strategy, to write a lot, but not to worry too much about the formalities of academic publishing. And so all the papers are available for free, and they are linked in the main Dogen page. So that was kind of what we've learned, I guess, with the PhD. I think it's probably worthwhile also mentioning the series of videos that we created, a playlist that discusses the methodology in detail. This was the material we used to prepare for the Viva. I think we probably need to create a single video that encapsulates the core ideas, as I mentioned in the release notes, partially because we weren't sure whether we were allowed to use material directly from the thesis or not. So we ended up not doing that, which makes some of these chapters a bit drier, I think. So perhaps we'll revisit this with a part 11. But as it is, if you have the patience, I think it's worthwhile going to the arc from part 1 to part 10. Should give you a good overview of how we got to where we are. And so with that, I think we conclude the demo for this release. I don't think there's anything else that requires mentioning. Okay, thanks very much for watching.